So for dividing, we simplify the fraction. So this is connected to what we did earlier with. Did it get missed? Let me look. Okay, so let's look at a couple of examples. So we can look with algebra tiles as well, but we're going to look at the work first. I think I'm going to skip the algebra tiles for today. So when dividing a monomial by a monomial, you look at the numbers first. So if I just looked at the numbers, can you see that I have 6 on the top and 3 on the bottom? If you had 6 divided by 3, what would you get? 2. So the first thing we're going to do is we're going to look at the numbers and say, I know that 6 divided by 3 is 2. Then the next thing we look at is the variables. On the top, we have x squared. That's x times x. And on the bottom, we have 1x. Maybe you remember the rule for dividing from your exponent laws. Or maybe if you think about expanding, can you see that x divided by x, that would cancel out and just equal 1. So what are we left with? X squared on top, x on the bottom. We would be left with just 1x. I will show you how the algebra tiles work. Okay? So you don't need to write this down, but I'll just give you a little, because I think your textbook has this for some of the algebra tiles and multiplication we'll look at first. When you're multiplying two things, the idea for algebra tiles is they make it like area. Remember that area of a rectangle is length times width. Okay? Does that, you remember that from our, okay? What they do for multiplying is if I had 2x's times 1x. You guys know what the answer is, because you multiply the numbers in front, you would get 2. Multiply the variables and you get x times x, x squared. Okay? With algebra tiles, what they say is make one of these your length, make one of these your width, and make a chart like this. How do I draw an X with an algebra tile? That was the long skinny one. So I put one long skinny one here and another long skinny one here. Can you see that that's 2 X's? And for the width, put one long skinny one here. What that makes is an area of a rectangle this size. What shapes fit into those? One, 2x squared. So they said if you want, you can use the algebra tiles to show that. And even if I take out the algebra tiles so that you can see that, the algebra tile system even comes with that chart built into it. So I can open it up, and if you ever want to use these on a quiz or a test, you can. I can put those pieces there. I'll come around and show each of you. Wow, if I can hold it without it falling apart. That you could put 2x on one side, 1x on the other, and the area that fills up is 2x squared. So that's the same as the picture that I drew on the board there. Beth? Kaden? You see that? Yes. So then, algetiles with division, if we look at the same example that we just did, which was 6x squared divided by 3x. What division says is this is your area and this is one side. So if I was setting it up on that chart, one side is 3 x's. So I could draw 1x, 2 x's, 3 x's. Do you remember why I shade them in? What's the difference between shading an algetile in and not shading it in? Right, the shaded ones are positive, the not shaded ones are negative. So if I drew 3 x's that way, can you see that you could make x squareds under those ones? 1, 2, 3. That would fit under those 3. But we need to make 6 of them. Can you see that I would need to add another row? 4, 5, 6. And of course, each of these would be shaded in because they're positive. If I did that, what would I have to draw on this side to get the other side length? Can you see that I would need 1x there and 1x there? And so the answer to this is 2x. And we can see it with algetiles as well. But generally, what we're going to try to do, if you want to use algetiles to help you, you can, but we're going to look at the numbers in front, 6 divided by 3, and simplify that fraction to get 2. We're going to look at the variables and simplify the variables and just get x. So here's our next example, 8xy divided by 4y. First of all, look at your numbers. Can you simplify 8 divided by 4? What is it equal to? It's equal to 2. Okay? Now we look at our variables. On the top we have an x and a y. On the bottom we have a y. Anything cancel out? The y's will cancel out, leaving you with just x. So the answer to this one is 2x. Okay, try this one on your own. Looking at the numbers first, the number we have, 27 on the top divided by 9, can you simplify that? That's equal to 3. And then we look at the variables. We have x squared on the top. If you like to write it as a repeated multiplication, you can. Does anything simplify? One of those x's will simplify, leaving you with just 3x. Okay? So now dividing can be written in different ways. We've seen it written as the fraction. We can have it also written with a dividing sign. So this is the same as this. Again, I'll let you get a head start on this one. Numbers first. The numbers, we have a negative 15 divided by 3. So now negatives are involved. Negative 5. And then we look at our variables. We've got an m and an n divided by an m. Does anything simplify? The m's and negative 5n. Okay, so what's going to happen is on page 260, and this is the right page because that was the page we were. I should double check, you're right. What's going to happen is we're going to take some time to work on page 260, and you have exactly 12 minutes to study dividing and multiplying, and then we're going to get another one of those, see how you're doing things at the end. I put the last one into the grade book, but it didn't count towards your grade. I don't know if you look at that or notice those things. So we're going to do that again, because one of the things I want to be doing as we go along is checking how well you know things.